Okay, can everyone see my screen?
Yes.
Uh, Thanks, Lauren. Yeah, will be great if there's some interaction so that, it's not like I'm talking to myself. Um, okay, so I have created this GitHub page to go through the topic today, which is comparing Snakemake
Okay,
and
those in the breakout rooms, I think you can start the workshop. There's still a few participants out there deciding on which workshop to join. So, but please go ahead and start on the workshop first.
right, okay. Um, yeah, so I think I'll start by giving you this link. So I pasted on the chat. On the chat. I just pasted on the chat. Can someone confirm that you can see it on the chat? Anyone? Right. Right. So yes. So, okay. So you can see it. Um, so I think first, let's just download some data set while I walk you through the workshop. So you see here on the data set, there is a link to download data set. This is if you want to do it hands-on and, like alongside me as I go through it. It's optional. If you just want to see how I do it, that's fine too. Okay, so this under data set, there's a button here for you to click and you can download from a G drive. Right, okay. So looks like you can access. Okay, yep. So yeah, as I was saying, the topic today is comparing Snakemake or versus Nextflow. But before we get into that, I will just show you like how to do the same with shell scripting, which is like how we used to do things before we have workflow managers like Snakemake, right? So that's uh, a little bit about me, and this is the table of contents for today. Hope you like this picture that I created here. This is using one of those new generative AI stuff to create image. So I just ask it to create something that has to do with Snakemake and Nextflow, and it comes out with this. Okay, so yeah, so we'll be talking about workflow management system. Um, so like, why should you learn it, right? So like for myself, I do a lot of genome assembly work. And if you're aware, last year the complete human genome was published. There's a telomere to telomere genome was published. So that one was done using the workcore assembler. And this is actually a Snakemake pipeline. So if you click on it, you can see that you know this one here is actually using um, Snakemake to do it. And And if some of you are working with, say, Oxford Nanopore dataset, and you have been using their customized pipelines, then you are probably aware of Nextflow, because that's the workflow manager that they use. So this is the epitome Oxford Nanopore pipeline. So there's lots of different Nextflow pipelines here. So yeah, so yeah, so learning these workflow managers, might be because some of the software tools that you want to use, they are in the form of a workflow manager. So the better you understand workflow managers, then when you run it, you have a better idea what is going on. Yeah. So some other reasons, reproducibility. So think of a container. So once you created the pipeline and you want to reproduce the run, it's much easier if you do it in using a workflow manager, right? Because you can actually what we call containerize the whole pipeline. So like all the software dependencies and your actual code, the main code, you can package all of them in a container, and then you can give it to someone else, and it should just work seamlessly for another person to reproduce your workflow. So that's a great reason why we do it, because there are many times that we have to muck around with different software installations. If some of you work in bioinformatics long enough, I'm sure you know what I mean. So yeah, so this will help to take care of the software dependencies issues. Efficiency. So if you're using shell scripting, that is running jobs in series, basically. And if you have jobs that, at the same time can be run in parallel, it's hard to do something like that with shell scripting. So a workflow manager will do that for you. And we will see that today. It's also easy to resume failed jobs. So say you have a job with 10 steps and 5 of them, no problem. And you come back, you just want to rerun it. It's much easier for you to do it with a workflow manager. Okay, so some prerequisites. I assume that you come into this workshop knowing some Linux, and you know how to install tools, because there's a few tools that I will use for this simple snake calling pipeline. And I assume you know shell scripting and some basic understanding of genetics and DNA sequencing, so that you know that when I talk about FASTQ files, you're familiar with that. So yeah, if you don't have this prerequisite, I guess you can still follow along, but you will struggle to understand what is being achieved. But anyway, the focus today is more on the workflow itself, right? Not so much about the science, like what kind of scientific interpretation that you can get out of the workflow. So yeah, so I've covered a few things already. Is there any questions so far?
No, I think we are getting good overview, and I think we are ready to move forward. Yeah.
Right. Okay. Thank you. Thanks for that feedback. All right. So yeah. So the first thing is I'll tell you.
I just wanted to interrupt for a second. Do we need to go a long way is needed, or we can follow your instruction and try later on?
It's up to you, Harpreet. Either way works for me. So I hope by now most of you have downloaded the data set if you want to try it, right? So by now I think you should have the data set. And once you have the data set, and then you still need to have the tools. So I'm not sure if you come in, like these are quite common tools. But if you want to be safe, you can make sure, like maybe you can download it using this bit here. If you're familiar with Conda, so you can create a YAML file like this. Inside this YAML file, you have the channels and the dependency software that you want in this Python environment. name of this environment is, this symposium 2023. So if you do that, you do so this assume you have Mamba as well, and then you will have all the software. Otherwise, you can try to install this software as we go along. But yeah, we'll see how it go, because you can just, so it's very hard for me to try to troubleshoot your system, given that we're doing it on Zoom. So imagine, 5 of you have problems running it, and I try to troubleshoot one by one. We'll be here for a long time. So my suggestion is you try to see if you can set up the tools, because that will be the main complication, setting up the tools. Once you have the tools, then running this, I expect no problem, because I have tested it. Yeah. So does that answer your question? Okay, so yeah, so the first thing I thought before I get into the workflow, I show you how what are these different tasks that I'm trying to string together here, so that you can see it one by one, and then you have a better appreciation what that workflow is doing. Okay. So yep. So after you downloaded the data set, can you see my console?
Yes.
Yeah, we can see.
Yeah. So after you downloaded the data set, so if you want to do the shell, so let's say you go into shell. So I just make a folder, shell version. And so all the, okay, so let me just clear everything here, pretend I'm doing it the first time, okay? So I will clear this one, clear this one. I gotta be careful not to delete important things. Okay. So this command here is the same as this one here, the shell script here. Right. So this one, you see, I put a note to myself to activate this to ensure I have all the tools. So that's what you need to ensure, that you have the tools. Right. The tools are not many, kind of like listed here already. So there's FastQC, Singular, EWA, Picard, SAM tools, BCF tools, multi-QC. So less than 10 tools. So you probably, if you work in bioinformatics, you probably have some of these tools already. So yeah, so basically, first thing is activate the environment, make sure that you have all the tools, right? So once you activated it, then you have the tools, right? So like if I go SAM, I have SAM, some Baba, I have SAM tools. Okay. So and the next thing is, so next thing is that data set that I asked you to download. It has 3 samples, sample 1, sample 2, sample 3, and their pair and reads, right? So sequence front and back for the same sample. And it has a reference genome. In this case, well, this is a demo. So in this case, I just use a cattle genome, and I subset the chromosomes to just 2 chromosomes so that it will run quickly for today's demo. Okay, and the reference genome also come with indexes for BWA and SAM tools, so you don't have to build, you just download and then yeah, we can use it. So okay, tools are available. Then the next thing, we need to have the input data set. So the input data set in this case, this one here will get the, because I have the data set, so I'm just getting one sample here to show you with the shell scripting. So get the reference, right? So after this, what you're looking at is just one sample, and the reference genome. Okay. So I'm not sure how I'm going with the speed. If it's is it too fast for some of you to follow if you're trying to do it at the same time? If it is, let me know. Okay, so the next thing, I think I'll run this thing one by one so that you know what I'm doing. All right, so you can see now my command shell script. Okay, so what I'll do is I will comment out the code and just run it one by one. It's very quick. Okay, so let me save this. Okay, so basically, I just want to define all the variables and just run the first one, the fastQC. Right? So fastQC is to check the quality of the raw sequencing data set. So with this, you can see, so what I did there in Atom is now basically is updated on the server. So we're just running this bit here, okay? So someone is asking 3 samples, 1 reference genome. So we are gonna discover the SNPs from these samples. So these samples are just sequencing reads of some random cattle samples, okay? It doesn't really matter what exactly the samples are because I'm just trying to demonstrate a SNP calling pipeline using workflow manager. Okay, I hope that answers your question. Okay, so let me run it. So the first thing is very simple, right? So it's just doing the cleaning up, not cleaning up, checking the quality of this one sample here. And so now it's done. And then the next step, and we can go and do the next one. And so now let's do the next one. So if you are in a hurry, you can do all of them. Just don't comment that. But I just thought I will, actually I do it the other way around. So I need to comment. I should comment this one. So this one is done. And yeah. Okay, can do like this. Run the second one. And right. Sure that is correct. Yeah, so now it's just running the second one, right? So that's checking the raw quality. This is getting some stats of the sequencing rates. Yeah, you can. Yeah, you can. So hopefully you can see your chat here. So I'm answering directly. Yeah, you can. You can just take any FASTQ, any genome, yeah, and index the genome. Then you can run this pipeline. So for example, later when I get to Snakemake, I will show you Snakemake tutorial has example data set that you can use, but that example data set is not a pair end reads. So that's why I give you some data set to practice here. Okay, so this one done the second step, which is doing a sig kit. This is to check the stats of the reads. So maybe it's a good idea I just go a little bit slow and so that you know what I've done. So the first thing is this fastQC. So you cannot see it unless you take this HTML file, you open it, then you can see the fastQC report. And the sig kit stats is basically just checking the sequences. So like these sequences here, they are basically pair and reads of 100 bases. And then this is the total number of sequences, bases in. So about 900,000 FASTQ pairing. Okay, so then next thing, let me shut this one. And then open this one. Okay. And run. So normally you don't do a slow motion like this, but this is so that you can appreciate the steps that I'm doing. So this step here is this step here is trim the law. So it's trimming and also getting rid of bases with quality less than 30. So it must be at least 30. And some clipping of the 5' and 3' end of the sequences. Pair and reads. And this is how many CPU cores you set it. So in this case, in the shell script, I set 8. So that's done. So this is trim the law doing it. Right? So we actually have some sequences being removed. Right. Okay, so then the next thing is do the next step. Okay. So there is a FastQC to check the quality before, like the raw read. So now that we trim it and clean it, so now it's checking the quality after the trimming steps. So this is this bit here. Okay, so then I think I'll run two, right? So just to speed it up a bit. So okay, clean that. I mean not clean. Check the quality of that, and then this is the trim one, and map it. Right, take the trim and clean reads and map to the reference genome using BWA aligner. Okay, so I'll just do these two steps in one go. All right, so now it's the FastQC step for the trim reads. Then when it's done, then it will do the, so this part here is the BWA alignment here. So it's, it'll just be very quick because it's not a big FastQ file. Just give it a second for it to complete. Is it all good so far?
Yes, sir.
Thank you. Okay. Taking this time. Okay, so I will continue to the next step. Doing stuff. Yeah, you have to give it a minute. It's done. Yep. Okay. So the alignment has concluded, and we can do the next step. All right. So the next step, I think we'll do a few in one go. So now we have reads aligned to the reference genome. The resulting file is a BAM file. And this BAM file is sorted as well. So it's sorted by coordinates, right? So chromosome 1, the like chromosome 1, position 1 will come up first, right? It's sorted. Okay, next steps, we're gonna mark duplicates. Because sometimes you get PCR duplicates and you may not want to use them. So we can use these two P-card mark duplicates to mark the these kind of duplicates. It's a soft marking, so it's not throwing away the reads. So this part here is mark duplicates. You get a BAM file. After that, index the BAM file. And after that, we can check the stats before and after mark duplicates. So this part here is before. So we're checking 3 different kind of stats of the alignment. So when you have a look at the file, you'll get an idea what kind of stats I'm talking about. So there's one before and one after, just like FastQC, you have one before and one after cleaning the reads, right? And this part here is optional. This is to split the BAM file by chromosome. Because when you call SNPs or call indels, that calling step can be done in parallel by chromosome. You don't have to do it in series, like chromosome 1 finish and go to chromosome 2 like that, right? You can just ask it to call variants per chromosome. So this will speed things up. So this part here is basically to get a BAM file, not BAM file. This is the part to get how many chromosomes they are in the deduplicated BAM file here. Then this part here is the part that actually doing the variant calling on the BAM file. So in this case, since it's only one sample, 2 chromosomes, so it will just do it twice, right? So if you can imagine in a real run, you will have like, say 3 samples, 30 chromosomes. That is actually 90, right? 3 times 30. So all these 90 jobs calling variants can be done in parallel. But with shell script, it's hard to do that, okay? So later you see with Snakemake or Nextflow is easy to do things like that. Okay, so this is basically it. So I will run the remaining steps. Okay, show it to you how it looks like. All right, so now it's doing the P-card mark duplicates. Yep, so it has completed mark duplicates already. And it's doing the next step now. Next step is doing all the stats. All the stats are done. The stats are, there's no verbals on those, just silent. So this part here is already the variant calling part, the last part with BCF2s. Okay, so it's done. So when it's done, you can see you have a lot of results in here. So let me maybe go back and okay, let's see. So you see this. This is the first one, right? The first alignment with BWA, the sorted band. And then this one is the deduplicated band file, which is this step, the mark duplicate steps. And you've got all these stats with the alignment. So like, okay, before we deduplicated it, So this is one kind of steps that we can get. So we send 2 steps. So we generated these just in case if you want to, if there's an issue with the alignment, you suspect there's an issue, you can go back and check these steps. Yeah, so so this one here is telling you like the mapping to the reference genome, because you only have 28 and 29. So yeah, you can, if you want to know like what's the meaning of these steps, you can just easily find out like 72 steps of today. What are okay. They are quite equivalent, so I don't see big difference between the 2 of them. So I think at the end, when you see both Snakemake and Nextflow, then you can appreciate that later. So maybe wait for it so you can see some of the runs. Okay, so this is basically it. These are the steps that I will run today, right? So so in the end, you get this VCF file, which you have the snips, right? So this is the VCF file, version 4.2, so you can see inside the snips. So this one is called VCF tools. All the positions are reported here. So this I picked these 2 to show it to you because it's quick. So if you have whole genome sequencing data, probably you want to pick something more, something like GATK and deep variants to do the encoding, right? So, but the purpose here is the workflow. So this is enough for us to string together a few things for you to see how something like Snakemake or Nextflow will work, right? Okay, so then now we are ready to go to Snakemake. Is there any questions so far with the steps that we are doing? You just need to understand these are the steps that we string together. You don't need to know like in details what each one is doing. Okay. All right. Okay, so Snakemake. So some info here on Snakemake. There's some key features here that are listed. If you want, you can read. But even better than reading is we're gonna do it hands-on, so you can see some of these features when I do it. Okay. So like this one, parallel execution, executing the workflow depending on different conditions, like maybe a job you want to give more CPU, maybe a job you want to give more memory, things like that, and automatically will map the input and output, logging, and with Snakemake, the difference with Nextflow is if you are familiar with Python, it's much easier for you to pick this one up, right? Because it's basically in Python, basically. And yeah, there's a community supporting different pipelines as well, okay? So both Snakemake and Nextflow, they are data flow programming language. They are different from programming language that you execute instructions in series. With data flow programming language, when you have input-output mappings, the moment a job has all the inputs that it needs, then it will execute. Okay, so this is different from running things in series. So if you print out, so with both Snakemake and Nextflow, you can print out this what they call a directed acyclic graph. It shows the mapping of the input-output of the jobs, and that will help you visualize what you're doing. Okay. All right. So we go to Snakemake next. So in the directory structure should be something like this. So you will have a few missing files because this is a completed run, how it looks like. So let me go to Snakemake. Okay. And so the sequences and the reference genome, they are inside here, okay? The sequence here, reference here. So I will pretend I'm doing a fresh run. So there will be no results, no logs yet, right? So let me just delete these results. So this .snakemake folder is how Snakemake keeps track of what has been run. So inside here is information on what has been run. So I get rid of it. So this is like this, running things from scratch. So to do Snakemake, you need a few basic files. So one is, of course, you need to have the tools ready, right? So these are some of the tools in the environment file. So you can specify all the tools. So this one here may be missing some, missing some that we are running. So you just need to make sure that you have all the tools here. But I'm now going to change my Conda environment. So this one here is what I created for Nextflow. So I'm going to deactivate this and use the one that I have for Snakemake. So this environment here, I hope you understand the concept of environment. Environment is like basically you want to install all those tools specific to it's like if you're familiar with R, for example, this is basically like running library, whatever the name of the packages. So you just want to make sure all those packages are available before you start doing anything. So this is basically that. So I'm making sure that all the packages are available. So what do I mean by that? I mean, all those tools we just ran, PCF tools, SAM tools, SIGKit, FastQC, all those should be available in this Conda environment. That's what you want to all the samples, you know. So like you can think of it as it goes through it once. It's like it's replacing this to sample one, and sample one, read one, sample one, read two, like that. And it also knows that there's sample two and sample three. How does it know that? Because in your config, you see here, samples, we have specified that. So it knows how to do the mapping in here. Okay. So then in output, it will place the corresponding one. So if when it goes through it is sample one, then it will put sample one here as well. So it does the mapping for you. And the command, if you remember in the shell script, is very simple one. It's fastqc, tell it how many cores, and then the input one, which is the read one, and then the read two, which is this one, and then the output directory that you want to send results to. And also, if you remember the shell scripting just now, when we run it, you see the verbals, you know, like as it's running, what kind of messages, right? That those we call verbals, they are coming out to the console. You can capture that in a log file. So this is the part that is doing that, right? So yeah, basically you save logs as well. So, okay, so this is how you specify a log. So you say, okay, log, this is where you want to put the log file, and it's doing the log per sample as well. Okay, so it's sending the log per sample. This is params. So this parameters, it depends, like maybe if this command has more arguments you want to specify here, you can. Right? So in this case, it's just a simple how many threads you want to run it. So this is just one param, and then output. Right? So this output is the output from fastqc, and it will do this. For example, sample one and sample one for r1 underscore fastqc.html. Yeah. So this is the first rule. So you can see there's a more thing you need to set up compared to a shell script. In shell script, you just do this, and that's it, you're done. Like that, without the log, and you're done. But you will soon see the advantages of doing it like this. Okay, so let's say the next one, we pick this one here. So this is trim the log. That is out of alignment a bit. Okay, so with this one, trimming the reads, basically, you know, it uses the same starting reads, same raw reads as this one. So then you specify it, and it's the same. And then this is the command, similar to what you saw in shell script. This is logging params. Okay, so you can see, even though more for you to write here, but it's repetitive. You know, you can kind of see the structure of it already. So you just maintain that structure where possible. And so now we do two rules already, and let's string together this one. Okay. So now you can see this rule is taking a different input. This one here, the read one, is this one here. Right? So the output of this rule is the input to this rule. And this is the command. It's running. This one. So this is the command that's running, similar to this one. But you can see there's a mapping from here to here, which Snakemake will do for you automatically. Okay? So I think you get the idea how I'm stringing together the rules. So I won't go and do all of them because we still got to do Nextflow. So let me just run it, right? So the snake file, the full snake file, the full snake file basically has all of this. all of them, just like how we did the shell scripting. It's missing the SIG part, but that is just, just one small step. So it will still demonstrate to you the idea of workflow. So there's one more thing. You need this rule all. This rule all is like gathering all the different rules that you're running. Like that is like the last result you want, like that. So yeah. So this rule all, this last step is getting the variant calling result, which is the last step, and the multi-QC report, which is the last step. Okay. So you specify that, then it knows that it's not complete until you have this rule all done as well. Okay. So when I run it, it will make more sense. So right now, this part here is for you to know how you write the syntax so that you can string together these rules. So once you have that, you have everything you need to start a Snakemake. Right? You've got a snake file, you've got config, environment. Now you're ready to run. So to run, this is what is called a dry run. This flag -n. This -n is not doing a real one. It's just mapping out the rules based on the rules you have in the snake file. We'll try to map it, and then tell you whether you have any issues or not with the mapping. So it's a good idea before you do a real Snakemake run, do a dry run to check whether you have any issues on it. So this one -s is to specify the snake file. So you can call it something else. If you can call it snake file 1 or snake file 2, up to you. You can specify it here. But if you call it snake file, you don't need the -s. It knows how to look for it. Likewise, I think config file, if you don't specify this, but you have this one, you name it this, then it knows that this is the config. But these parameters here allow you to specify the files explicitly. Okay, so this part, run it. So it's a dry run. So you can see in this dry run, we have 3 samples. So the 3 samples will do this fast QC step. There are 3 jobs. And then trimming the 3 samples, again, 3 jobs. Run fast QC on the trim reads, 3 jobs. Then you do BWA alignment, 3 jobs. Mark duplicates, get a BEM file, 3 jobs. Core variants on 3 samples, 3 jobs. Multi-QC is bringing in all the QC report. In this case, I only specify the QC report from fast QC before and after trimming. Give that to multi-QC. So that's just a 1 job. And then finally, that 1 job to make sure that you have all the output that you need. So this always, as far as my experience is always there. You always need to have this one all rule. Okay, so this is a dry run, right? And as it says here, the order of jobs does not reflect order of execution. Okay, so they just map it like these are the things they need to run. In the actual run, it will know like which one to run first. Okay, this is just don't look at the order here. Okay, so we are ready to do a run. Okay. All right. So next thing, actually still not run. Run is the last step. This step here prints the directed acyclic graph. This is the graph that shows the mapping of your jobs, right? So if you run this, so that's it, done, and it will print out these DAG SVG file, which you can open in a browser like Chrome. You can see the mapping. So how does it look like? It looks like this. Okay, this is the directed acyclic graph. So with this, I hope it's making sense to you. So with the raw reads, the raw rate is doing this job here. So like this is sample 1, sample 2, sample 3. It runs, and when it's done, it's giving it will gives the output to multi-QC, right? And then the raw read will be clean and trimmed with by trim galore. So sample 1, sample 2, sample 3 like this. So the trim reads after that goes through this fast QC checking step. When it's done, it's giving its output to multi-QC. Then it's doing the same thing for all 3 samples here, right? So you see all 3 samples will give to this multi-QC. The trim reads, they are the input for alignment, for the BWA alignment. And so like sample 2, for example, will be aligned and then mark duplicates and then covariate. Likewise, sample 1 is doing the same thing. Sample 3 is also going through the same path. You see here, right? So when covariant is done, then we can merge it here to say that, okay, I'm satisfied, covariant is done, and multi-QC also done. Only when multi-QC and covariance for all samples are done, then that I consider that this is done, right? So you see now Snakemake basically knows how to map all these things. And because it has this graph, now it knows in what order it should run and which one can be run in parallel. So sample 1, sample 2, sample 3, for example, they can, for example, this step can start running, this step can start running simultaneously. If there are enough calls, they will just start running because it doesn't depend on anything else. It has all the inputs it needs to start. So that's the difference with shell scripting, right? So with shell scripting, you may write a for loop, and that for loop is doing sample 1, sample 2, sample 3 in series. But in this case, it's actually doing like checking the quality, trimming it, and checking quality, trimming at the same time. And the moment it's available, then it goes through the next step. Okay. So this is the important thing to understand about Workflow Manager. Is there any questions so far? Okay. No question. So I will go to running it. Okay. So this is the actual. So when you see that I change it from -n to -- cores and give it how many cores, this is running with 16 CPU cores. This is the actual run, okay? So this is the magic, all right? So it's running it right now. And as it's doing it, whatever jobs that got completed, you will see it reports like how many. Yeah, it's going too fast, right? So 25% done, 30% done. Yeah. So if you look at the cores, you can actually see, but I have other jobs running, so you cannot see the core utilization because in my server I've got other things running, but you can see how it's executing the BWA MEM at the same time for the 3 samples, sample 1, 2, 3 at the same time. So it's doing all these things. So when you run it, you basically can see utilization of the core and memory. It just know how to do this for you, okay? So if you're wondering, I'm just running htop command to see utilization of compute resources. So that's the cool thing about doing a workflow, using a workflow management system. When you run it and when it's very efficient, you can run htop and you can see that it's utilizing all the cores and utilizing enough memory to do stuff. And that's very satisfying because that means you are you are using your compute resources to its potential. All right. Yes, Anab, Dr. Anab,
Hello.
what's your
Hello.
question?
Hi. Yes. Am I audible?
Yeah, I can hear you.
Okay. So in what basis you will decide the threads based on your work? So it's not a random number. So what basis we should decide the number of threads in your system? Means whatever server or the system we are working.
Yeah, look, there is this it depends on the job that you're running. So you if I may suggest, you can experiment like if you increase more core, does it go like a linear increase, right? More cores just run a lot faster because some jobs um like 8 cores versus 16 cores, it's just not much difference at all. So for those jobs, you don't need to specify 16 cores. It's like a waste of resources. So it depends on the jobs. You know, some jobs can scale. The more you give it, and the more it will consume and run faster. But some jobs are not like that. So so to know that, you can do things like you can check it yourself. You can benchmark it. Like what was that command? Was it time? I think it's time, the command, that benchmark. You can benchmark it, like try, yeah, in time can help you benchmark it. So you need some sort of benchmarking, right? Try like 4 cores, 8 cores, 16 cores, 32 cores, and then see if you get better performance if you keep increasing it. But if you don't, you get to a point you don't, then don't set so high. Does that answer your question?
Yes, I got. But the question is, for example, I have 10 samples. Okay, so I want to run parallelly, not by after completing one and the second one. So
Yeah.
for example, in some course, I have just scheduled the task for some process, and for the another core, I want to schedule for the another samples for another sample. So is it possible?
Yeah, you can. So you see here inside the rules, these rules here consume 4. But you can alter this yourself. So let's say you have 32 cores, and that's all you want to give it. Then if you use a lot here, then if I'm not mistaken, that will slow down the next sample coming in, because you are putting more cores for this job. If you put less, then more samples can start in parallel, but each job has less cores for them. Does that help?
Okay.
You get what I mean? So if you put less here, more samples can be run at the same time. If you put Yeah, but when they run at the same time with less cores though. But if you increase this, then less sample will run at the same time, but each one has more cores to run. So the question is, which one is better?
Okay. Okay. So it's a decision making. So based on your number of samples and the capacity of your server.
Yeah. So when you see this step here, the step that
Thank you.
we start with just now, this step here. Yeah, thanks for the question. Yeah, so this step here, you specify how much you have. So I can jam this thing up real high just now, and you will see that when I run this, it will use a lot of cores here, right? This machine has 256 cores. So if I do that, probably you'll see it maxed out here. But I did it on purpose. I don't want to set so high cores because I'm running another job right now.
Yes.
While I'm conducting this, because I don't want to compromise the other job. But actually, server, they're smart. They most likely won't do that. If you run Snakemake, you ask for a lot of resources, it knows how to balance it. Most likely, it won't crash your other jobs. Okay, but it's just that in this simple demo, I don't see the need to do that.
Okay, thank you.
Yep, so it's 90% done. Now, yeah, now I think it's mainly, so two more steps left. So that means that you have to rule all. That's the last step. Yeah, I think it's one more sample to call variant and rule all the last rule. Once that's done, then it's all done. Okay. So yeah, it's all done. So let's have a look at the results. So this one I showed you already. This one is basically this thing here, right? So I recommend when you build a new pipeline, have a look at your directed acyclic graph. Because if there's any issue in how you map things, then it will come up here. And okay, so all the results are here because of how we specified the rules. So you see, we put the output in here in results, and then within result there are subfolders where we put things. So this is nice, right? This is neat because you control where you put results. So if you look at the shell version, I guess I purposely make it messy as well. You see, if you just do one sample and all the results come out here, can you imagine if you have like 100 samples? Yeah, but shell scripting, you can also organize it too. Okay, just that, yeah, you gotta write more code for that. So the results, exactly like the one that we saw earlier, right? So this is the raw FastQC results. Right, as HTML, the zip file, and then this one is the trim results, and then okay, that's the FastQC result. That's the trimming results, mapping result, mark duplicate results, variant column results, and the multi-QC. Okay. So multi-QC, if you haven't used it, it's a good idea to use because this multi-QC file, let's see if I can show you a multi-QC example. And maybe I'll show you exactly this one. All right, let me just go get this multi-QC file, show it to you. This HTML file. It's good to have. Because it saves you time from looking at QC report of samples one by one. Right, so this is multi-QC. Now it has taken the samples before and after trim the law. So this one is sample one, the raw. This is after trimming and cleaning. So yeah, not much difference before and after. Right, so you've got okay, sequence count, a bit less after you trim and clean. That's expected. And like, what's the quality like before and after? So with multi-QC, you can actually ask it to like with alignment, you can also pipe that in here so that it will display the QC of the alignment as well. So you can get all sorts of reports with that, more than you will look at. So yeah. So this one I find multi-QC for FastQC is useful because when you have, say, more than 10 samples, it's hard to look at FastQC one by one. So this is helpful. Yeah. So yeah, so all the results are here, right, in its individual folder. And one of the features of Snakemake is logging. You can log all the runs, right? So when it's running here earlier, well, there's some verbals as well printed here. But after the completion of the run, you get the logs of all your jobs as well. So this is very useful for you to look back at your job, say 1 week or 2 weeks from now, right? So you want to know exactly what happened to that run this log will save info about that run. Okay, so this is it. This is Snakemake. I'm gonna move to Nextflow. Do you have questions on Snakemake? Okay. If no questions, I will move to the next flow. Yeah, you see DSL, that means domain specific language. And in this case, we are using the version 2, DSL2. And just think of it like a kind of language, right? Like shell scripting as a language. And so you specify this at the top of the Nextflow script. And so yeah, this thing is just another way of saying similar things to Snakemake. Okay. I will tell you my conclusion later on. How do they compare? But bear in mind that I also just recently started to look into Nextflow. So I use Snakemake more. Only more recently I use Nextflow. Okay, so just bear that in mind. So some key features here of Nextflow. Okay, they're just different words, but really similar to Snakemake. And the main thing is this one here, containers. Okay, so Nextflow is supposedly a lot easier once you got your workflow working for you to containerize it. Okay, and that means you can reproduce the result on a different machine, send it to someone else to reproduce much easier. Okay. So there's some tutorial here I recommend. I forgot to say that for Snakemake, there's a tutorial here as well. So this tutorial here is super useful if you're learning Snakemake for the first time. I recommend you see that. And then with Snakemake, the link there, there's another paper as well on the history if you want to know. With Nextflow, I don't find like a super good tutorial yet. Maybe they are, but I haven't found one. So this one here is basically how to install Nextflow itself, but it doesn't teach you something like more bioinformatics specific or something a bit more complicated. So that's why I don't find it super useful from the Nextflow website. But this example here may help you if you want more information than just what I will show you today, right? So this one is BLAST. So, you know, this one here show you how to do BLAST, and it has the input and output as well for this input and not. Okay, so same thing like before. This is the directory structure, right? If you're gonna run it, and this is after the run, so you don't, some files are missing, you know, for now. And so let me go and get the Nextflow set up. Okay, so again, same thing. I will get rid of, because I did a run before, so I need to get rid of some stuff. Pretend I'm doing a run for the first time. So these are the ingredients, if you like, that you need to start Nextflow. You need to have a conf. Let me just go in sequence here. Let me just follow this. Okay, you need to have a YAML file. I think it's possible for you to skip this, but it's a good idea to have so that you know what tools you need for your run. So these are the tools we need. So like if you're practicing now, if you just make sure you have a YAML file like this, and then get Mamba installed. So to install Mamba, I think in this Snakemake tutorial, which is one of the links, I think it tells you how to install Mamba there, right? Installing Mamba folks. So if you do this step here, you can, after that you have Mamba. Mamba is like Conda. Yeah, that's why they sound similar, I guess. So you create this YAML file, and then basically, create an environment based on this YAML file, and then you will have all these tools in name in this environment name this symposium 2023. Okay, so I have done that already, so I can just activate it, right? So again, let me just deactivate this one, and then I will activate this one here. Okay. Activated this one. I have all the tools now, like these tools. Okay, then the next thing, you need to have a base config. This base config sits in conf folder, right? Put it in here. And usually you don't change it unless you have a strong reason, like you want to introduce a special process, then you change it. So basically this one here is like you specify process, right? Process. And then within the process, there are these labels for you to say, if there's a job you just want to run with one CPU, this is basically called a process underscore single. If there's a process with low compute requirement, process low. Then there's medium requirement, high, heavy, right? So like if you are familiar with using GATK, for example, maybe some of the steps you want to use high, right? But some of the steps, like FastQC, you don't need. You like probably process low is fine. Right? So that's the neat thing about Nextflow. You can, with the base config, it basically partition the compute resources for basically CPUs, memory, and time into different labels. So you don't need to go into each rule. Like if you remember earlier with Snakemake, in the rule, in params, you specify how many threads, memory, if you want to specify that. You specify that per rule. Whereas this thing here, you have this one base config, and then you just use it. Now, having said that, maybe Snakemake has a way to do the same as well, okay? It's just that with Nextflow, this comes kind of like most of us will use it like this, where Snakemake, even after you go through the tutorial for quite a lot of stuff, that they still don't show you something equivalent, okay? So yeah, so this one makes it easy for you to just specify what resources you want. Okay. And then a config, the Nextflow config. Okay. So this one here, it says here include the config file, which is this config file here. That's the name of my postdoc, by the way, to prepare this Nextflow pipeline. Max CPUs to use, 16. This is where you install the all those tools just now. You remember here when we run this thing here? Then we have this InSyB2023 environment. So this is where you point it to that environment. Okay. So when you run it, yours is different because after you install it, you have a different path. So this part you need to change. Make sure you point to yours. And then we call this the conda underscore local. So this is when you run Nextflow for this pipeline, you say, go and find this Conda local environment. This is where you get all the tools and use it. Okay. Then there's another function that that he implemented, which is to check the maximum memory time and CPU. Okay. So yeah, you can basically just reuse this. This is the main part to change. That's it. Then sample sheet. This sample sheet is how you specify the samples. So like sample ID, read one, read two. So if you remember earlier with Snakemake, you have a config, and then a config you have sample, and then sample one, sample two, sample three. So in this case, we modify it to take from a sample sheet CSV. Okay. Yeah. So that's read one, read two there. Okay. Then the next thing we need is the main Nextflow file, this main.nf. So this is the equivalent to snake file, right? So in here is where you specify all the rules. But in Nextflow, they don't call it rules, they call it process. It means the same thing. Yep. So this Nextflow file, you say use DSL version 2, domain specific language version 2, and then there's some parameters, right? Like accepting a sample sheet, which is this sample sheet here. And then this is where it will send the output, which is the current directory, and then in the results folder. A reference, this is for reference genome. At the start, it's set to now, so you can provide a reference later on. In fact, you have to, otherwise the pipeline won't work. Okay. So it's checking inputs here. Just make sure that you have sample sheet specified and you have the reference, which is this one here. And then this is the info. Print out this info here when you run, so that it looks nice. And this is the part that is doing the jobs. So it starts with, okay, so you have your data set, right? You have your FASTQ files and your reference. They are physically somewhere in your computer. That gotta be mapped. That map, to take that data and map it to processes, that's the channel, right? Just think of it like a pipe. Right? This pipe is piping your raw FASTQ file and the reference. Yeah, this is the pipe. So this pipe is saying, okay, where are you gonna get that data set from? Getting it from that sample sheet, right? The sample sheet says sample one, where's read one, where's read two. And then it will split it, split the CSV, and say header true. So if you remember, it has this. So it's basically header is true, split it, and then map it as a tuple. So a tuple, basically think of it as an ordered list. So this ordered list basically is keeping track of sample one is linked with this read one and linked with this read two, right? And then likewise sample two and sample three. So there's a collection of tuples here, collection of ordered lists. Right? So this thing is then the samples that's being processed by the rules. So later on, you see here these rules, like for example, this rule FastQC raw or process is acting on this sample, right? So this sample here now is holding three samples. Just think of it that way. This is equivalent to like that curly bracket samples that you saw in Snakemake in a snake file. So if you want to view that, you can uncomment this to see it. This is comment in this syntax here. Okay, then after that we import the processes. Okay, like I said, Nextflow, they call it process, same as rules. So in this case, we put the individual process in under modules just to keep it nice. So there are 3 modules: QC, mapping, and core variants. And here's the workflow. You define the workflow. So the workflow start with fast QC raw. This process actually comes from QC module. Okay. So inside QC module, there is this, like the code on what to do with this. Just think of it as a function, actually. This, like in mathematics, function. So this function act on the samples, and then it will spew out output, right? How many outputs? It depends on how you specify the function. So this thing will only spew out one thing, which is the FastQ raw report, and then it basically got captured here. And trim galore, another process, takes the samples, and then it gives out 2 outputs. So the order of the output that you mentioned here will come out accordingly. Okay, so it depends how many you have. So then, yeah, so you just map a series of these functions here, similar to like how you saw in shell scripting and Snakemake, right? So basically it's doing all this mapping here, which is exactly the same, like what you saw. So basically it has all the cleaning, all the trimming, checking quality, mapping, mark duplicates, core variant, multi-QC, all of that. So this is the mapping of it, okay? It's doing this mix, flatten, and collect as well. If you want to know what it means, you can read a bit more, but basically this is how Nextflow collects results. Okay. If you want to know what's inside all these individual modules, what's inside it, so this is the QC Nextflow file. That's how a process looks like in Nextflow. So kind of similar to Snake file, right? The rules in Snake file. So you have a name for it, and then you're tagging what's the name of this process. Tag is like a name for this, so that when you want to track what happened to this process, you use the tag. This label load, process load, is coming from here. There. See this base config. So that makes it neat, right? So you just say process low, and it knows how to use this. 4 CPUs, 4 GB, 8 hours. So that's basically the details of this process here. If when you run and you get into trouble, you know that this process is causing trouble, you can debug it. You can uncomment this and debug this, just this rule. So we won't run it because all these rules are working fine. This is where you want to publish the results. So this is the out directory, FastQC raw. The mode is copy. So basically copy all the results, keep a copy. So with this mode, it's safe, but at the same time, it will when you run it, if your results are big, the more you run this, then the more space it will take up, because you are actually making a copy when you run. And save as, so like these rules here. So just like Snakemake, when you build the rules here, you need to know like how the output looks like, so that you can write this part here, like what to save. So with FastQC, there's an HTML file and there's a zip file, right? So that's so you're saving both of them. And in fact, with Nextflow here, we are doing something fancy. It saved the HTML file to here, FastQC raw, but then it makes a zip folder and save the zip all in them. So you can actually control things like that as well in Nextflow. The input is this tuple here, which if you remember, when you do this channel, this is the tuple, right? So now it has mapped the sample one, read 2, and is using it here. And that's the output, and that's the command, like similar to Snakeflow rule, very similar. So that's one of them. If you know how to create one of these, then you know how to string together the rest. So you can see it's actually quite similar. The syntax is a bit different, different ways of controlling things, but has a lot of similar ideas, right? Okay, so with this, now we have all we need to run, right? We have the base config here, we have the Nextflow config here, the main Nextflow file. This one is just to set things up. And the modules, inside the modules are the individual processes or rules in the Snakemake terminology. And this sample sheet specifies the sample. So, okay, so now we are ready to run. Okay, so to run it, I activate Nextflow because my Nextflow command is in Nextflow environment. So if you're wondering how you're gonna get Nextflow, yeah, because you need to have Nextflow first, right? It's in here. This tutorial here will tell you how to install Nextflow. Yeah, installation. Okay. So this is how you get it up. Back here. Yep. Yeah, so I'm done with all this. Okay, this is how to run, right? So I'm running. Okay, so pay attention. This is where the magic is. Yeah, run. So I hope you are seeing this. So you can see like got this nice info display here. Because we did that in Nextflow config, right? And in fact, Nextflow is quite funny. It will keep changing the name here for some reason. Each time you run it, the name is different. So that you won't feel bored, yes. So yeah. So you see here, it's doing it and it's updating you as it's running, right? So some people prefer this sort of update compared to Snakemake, because in Snakemake, if you remember, like they just output it to the console and you get a lot of things going on. Whereas in Nextflow, it just updated like that. It just keep changing this part like that. Yeah. And I didn't include it here, but I saw some other people doing Nextflow. They can make a graphical user interface of this so that they can display it in a browser as the job is running, like this sort of stats here, what level of completion, they can actually display it in a browser. So that kind of nice to look at, but I haven't figured out how to do that yet. Okay. So yeah, so it's doing similar things that we saw before, just that now this is the Nextflow flavor. How are we going? Is there any questions so far? You guys are still here? Right. Almost done. So you gotta pay attention to this, like kind of fool you thinking that it's done, but sample 2 is still doing this. Then after that, sample 2 gotta go through this. And then this needs to be 6 actually in the end, right? So sample 2 hasn't gone through. So yeah. So you can see that it's running things in whatever order the resources is available, right? Kind of like sample 1 and 3 done, then only go to sample 2. Yep. There you go. So it's telling you it's completed. So this is whether you're doing Snakemake or Nextflow, it's important to look at this final bits here to make sure that it's a success. So like Snakemake will tell you 100% success with all the rules. So this one here will do like this. If it's all okay, then we'll just show you like this. Okay, so in terms of results, so you can see when it's running, it will make this work folder. This work folder is the one that it copied everything to here. That's the part that I said, if you choose the mode copy, it will just copy stuff and makes your results big, right? It's copying things. But the good thing is as you run, you have everything as well. Yeah, you see here, so it's saving. Yeah, it's got all these things. But it looks like this one is not a copy. It's just simulating. This one is a copy. So yeah, so Nextflow will do its own thing, how it keeps track of things for you. You can see this is internally, it just manages all these things on its own. Then in results, this is how you have specified it in the Nextflow file. Right? So same thing, you've got your FastQC results. Yeah. You see, these are all the HTML, and that's the part, the zips that I told you just now. You even arrange the zips all in there. So arrange it nicely. Yep, otherwise, very similar to Snakemake. Okay, and this is the DAG file, which you can visualize it. Actually, it looks quite nice. It's nicer than this. This is a PNG file showing the directed acyclic graph. Right? So it's similar to Snakemake, but it has its own, because it's Nextflow, the way it's doing things is different. It's taking the raw data and then make the channel, or what I told you, like a pipe. And then that pipe is now processing the CSV file and then created the mapping. Then you have the 3 samples in tuple, remember? So that tuple then goes into it's all this parallel runs. And then yeah, in the end, you get this multi-QC and so on. I think the HTML, let's see if I can find it. Actually looks quite nice. Yeah, this one. This one. Yeah. So you can get it to print out the HTML file and then you can have a look. So this one looks nicer than that, but it's actually the same thing. Just a different representation. So you can see, as you take the read, what is doing, or the different processes that it's doing. Yeah. Okay. So what's my verdict so far comparing the Snakemake and Nextflow? My verdict is learn both, because there are people creating pipelines with one of them, right? So like, for example, in my work, I want to do the genome assembly with workflow, which is in Snakemake. And I also want to learn oxonanopore pipeline, so that is in Nextflow, right? So if I know something about it, when I run it, it just makes my life easier knowing what's going on, right? If you're gonna build one, then pick one to learn carefully. Like you can actually write all these things and build your own customized pipeline. So for that, I would say the choice between Snakemake or Nextflow is, so far I don't find like a super big reason why you will prefer one over the other. They both can do the job, except there's one thing which my postdoc is trying to convince me is it's much easier for you to containerize everything with Nextflow. Because apparently you just need one argument, then you can make like a Docker of all these things. Then it's easy for you to send it to someone else to reproduce the whole thing, which is a problem for us working in bioinformatics, because as we create pipelines and then update the software versions and things like that, maybe one person is doing it, right? And that one person is doing it, he may have updated things, and then, but on your machine, you're still using the old version. So then, you know, over time, there may be clashes. So if that person is doing it, it's done, the pipeline is done, then he containerized it and then send it to you, then that will ensure reproducibility. So that's why I'm learning Nextflow actually, because it's supposedly doing this container part much easier. But I haven't got that far actually to test all these things. If you are using Python, you may be inclined to do Snakemake because you already know Python, and so it's not that hard for you to pick up the syntax and all that to do Snakemake. So yeah, so both of them do the job. Okay. Is there any questions so far? Because if not, we are near the end. Okay. There is no question, organizer. I think they are ready to go.
Okay, thank you, Dr. Lloyd, for the very insightful and informative workshop. And I hope everybody has enjoyed the session as well. We have received the request for the recording of this session to be made available because the participant wanted to join both workshops. So that will be made available after this. Any update will be communicated via email. If there are no further questions from our audience, thank you again for joining the 7th InSyB. We hope you had a fruitful session from morning all the way until now. It's 3:44 p.m. in Malaysia. And we hope to see you again. Thank you, everyone. And yeah, we see you again. Thank you.
Yeah. Can I just say one last thing? I probably will make the GitHub available for another day or so. So if you want it, you please go and get it. Because after that, I may shut it down after that.
Okay, thank you. All right, with that, I will close the room and we will be in touch if there's any update. Thank you, everyone.
Okay, bye-bye.
Bye-bye.